Hello friends, today we will discuss the concept and also derive the addition of velocity relation in relativity. This is very interesting concept in theory of relativity. So let us start with the discussion and derivation. Now suppose there are two frames of references, two inertial frame of references. I have already discussed about this. Okay, this is frame S, that is stationary frame. Frame S, that is stationary frame. Observer O, x-axis, y-axis and z-axis. And suppose there is another frame of S that is at the same position as the frame uh, S. Okay, there is another frame S dash which is at the same position, as the frame S. Okay, so X is X dash, Y dash and Z dash. Now this is at time t is equals to t dash equals to 0. This is at time t is equals to t dash equals to 0. Now after certain time, the frame S dash will start moving along x-axis, with a uniform velocity v. Which frame? Frame S dash. Observer O dash. This is x dash, y dash, z dash. Okay. Similarly, here it will be x dash, y dash, or y prime, and z prime. Okay. So stationary frame is here. This is just like that. Suppose there are two threads. There is a race and athlete 1 and athlete 2. Okay, first athlete will start moving with a velocity v along x-axis. Okay, so this is stationary frame which is not moving, x-axis, y-axis, z-axis. Okay, this diagram you have to remember. Okay, this is very easy diagram. So suppose an event occurs. In frame S dash at position P. Suppose an event occurs at frame S dash at point P. Okay, at position P. Now that event maybe, suppose this observer has a cap, this observer has a pen, and he has thrown this cap or pen. Okay, so this is the event. Now now there will be a velocity of this event, or this particle also. The velocity component of particle P or event P from observer O dash in frame S dash will be ux dash equals to dx dash by dt dash, uy dash equals to dy dash or dt dash, uz dash equals to dz dash by dt dash. Okay, by dt dash. Now these are the components of velocity according to the observer O dash. Okay, suppose these are our equations 1a, 1b and 1c. Now velocity component of particle P from observer O in frame S will be ux equals to dx by dt, uy equals to dy by dt, uz equals to dz by dt. Okay, equation 2a, 2b, 2c. Okay, now these are our 6 equations. Now from Lorentz transformation equations, that is x dash equals to x minus vt divided by root of 1 minus v square by c square, y dash equals to y, z dash equals to z, and t dash equals to t minus xv by c square divided by root of 1 minus v square by c square. Now these are the Lorentz transformation equations for space and time. Okay, we will use this result. I have already derived this result. Please see my playlist of relativity. Okay, so 3D. Now differentiate all these equations 3. Differentiate equations 3. Okay, so this will become dx dash equals to dx minus v dt divided by root of 1 minus v square by c square. Equation number 4a. Similarly, dy dash equals to dy, dz dash equals to dz, dt dash equals to dt minus minus dxv divided by c square upon root of 1 minus v square by c square. Okay, 4b, 4c, 4d. You have to differentiate these four equations. So it will become dx minus v dt, dx minus v dt. Okay, we are differentiating with respect to time. Okay, dy dash equals to dy, dz dash equals to dz, dt dash equals to dt minus dxv by c square divided by root of 1 minus v square by c square. Now put equations 4a and 4d, that is dx dash in dt dash, in equation number 1a. In equation number 1a, here it is ux dash equals to dx dash by dt dash. Okay, so put equations 4a and 4d in 1a, in 1a. Okay, so 1a will become ux dash equals to dx minus v dt divided by dt minus dxv by c square. Okay, because the numerator of 4a and 4d, numerator of 4a and 4d same, they will cancel out, so you will get this result. Okay, ux dash equals to this. Now divide numerator and denominator of right hand side. Divide numerator and denominator of right hand side with dt, okay, divide with dt. Okay, divide right hand side numerator and denominator with dt, so ux dash will become dx by dt minus v, dt by dt is 1 minus dx by dt v by c square. Okay, you will get this result. Now what is dx by dt? This is equation number 2a. This is equation number 2a. ux equals to dx by dt. This is equation number 2a. Now put equation 2a in above equation. In above equation, you will get ux dash equals to ux minus v divided by 1 minus uxv by c square, equation number 5. Similarly, by putting equations, okay, similarly by putting equations 4a and 4d in equation 1b, then we will do dividing the numerator and denominator of right hand side with dt. Same steps. Okay, now you will put 4b and 4d. Earlier you have put 4a and 4d. Okay, steps are same. You will get uy dash equals to uy root of 1 minus v square by c square divided by 1 minus ux v by c square, equation number 6. Now similarly, by putting equation 4c and 4d in equation 1c, okay, again dividing the result by numerator and denominator by dt. Okay, you will then putting equation number divided by dt, then putting equation 2c. Here you will put by dividing, after you will put equation number 2b. Okay, steps are same that you have to do. Then you will get uz dash equals to uz 1 minus v square by c square 1 minus ux v by c square. Equation number 7. Okay, now equations 5, 6, 7, they represent the addition of velocity relation, as observed by observer O dash. Okay, as observed by observer O dash. Now from the observer O, in frame S, the relations 5, 6 and 7 will become ux equals to ux dash plus v divided by 1 plus ux dash v by c square, uy dash root of 1 minus v square by c square 1 plus ux dash v by c square, uz equals to uz dash root of 1 minus v square by c square 1 plus ux dash v by c square. Equations 8, 9 and 10. Now previous relations from observer O dash, what you were doing, you were putting 4b and 4d in equation 1b, or 4c and 4d in equation 1c. Okay, now here you will put equations, these equations 3a and 3d in another equation, of equations 2a. Okay, you have to use those results. Okay, so 4a and 4d, here you have put 4a and 4d in 1a. Now if you want to derive these results, then you have to put 3a and 3d in 2a. Okay, so results will be same, change will be of sign. Here, like there is a minus sign, but here is a positive sign. That is due to direction, because according to this observer, if this frame is moving along this direction, then according to this observer, this frame is moving along the opposite direction. Okay, so in general equation 8 can be written as u is equals to u dash plus v 1 plus u dash v by c square. Equation number 11. Okay, equation 8 in general can be written as u is equals to u dash, just remove the direction symbol. Okay, 1 plus u dash v by c square. Okay, 1 plus u dash v by c square. Fine. Now for this case, the general relation will be u dash equals to u minus v 1 minus u v by c square. If the frame will be different, here the frame is O dash and here the frame is O. Okay, now if there is a special case also. Now what is special case? Special case is if v is very less than c. Okay, then v by c square will be neglected. Okay, it will be neglected. Okay, so if it will be neglected, then this will become 0. Then this equals to u is equals to u dash plus v. This is just that you have discussed, you have studied in your class, in your earlier classes, that u is equals to u dash plus v if the objects are moving in the opposite directions. Okay, so this is all about the addition of velocity relation. I hope you have understood. Just revise the derivation and you will be able to do so. Thank you. Thanks a lot.